just a lost weather balloon. An Air Force spokesman confirms tonight that this was no flying saucer.
Okay, guys. First, it's a great day. Like I'm saying, I'm very, very excited. I'm just gonna run real quick overview at my new upgraded rotary switch. I have used dual brushes at an angle, and anyways, I'll go in detail about this. And I also got a bigger motor, which I will also render all the info on it. Basically, my commutator is a 20 elements. So I originally had the two ends at each at a horizontal line, but now since this connection change, I have split two, and I mark them in blue as well in the other side, which is right here, and they must be in a perfect line across from the center of the shaft. That way you keep a symmetry, which is maintained at the commutator. Now let me put it this way. I did this wiring this way in order for you guys to see it. For me, it's better to run it from inside the toroid like I had it before, and had the toroid set here and do it. But this way you'll understand it, I believe so. So this was my previous joint where the whole thing closed up, and I just spread them apart. I'm trying to keep somewhere around a 30-degree angle according to inductor's law and whatever. But anyways, I kept them a little bit separate. We can play, like I'm saying with this. It's better that you make them so you can move them. They're the same continuous wind around the whole thing. I haven't changed that. I just removed some of the connectors here, and then these are gonna be my new two terminals for supposedly going to the primaries. Now, the way the commutator, I did the splitting, and just gonna see if I can put it forward to the cam so you guys can see it. I have broken in two halves. I split it. So first thing that I did was the two ends terminals, I set them perfectly horizontal. Then the next two, right above and below, I joined them together, which is this first coming from here, this first cable here, which joins this upper right next to it. Let me go this view here. So what I'm doing is this one right here and the one below the blue are going to be joined, and so this one and the following below, the second one below, and so this one, and so this one, and here I end this whole side. So that means I have 8, I mean 4 above, 4 below red wires that are split. And then you keep the same order here from your ending terminal. So these are the next two right next to the end terminal. These are the second row, and these are the third row, and these are the fourth row. And so the way you do it in order not to get lost is you go back to the other side end terminal and do exactly the same thing. So the next one will be, the next joint will be the upper and lower, above and below this the end terminal, and so on. And then you just wire it, and I'm just gonna take it for a small drive. I have the upper that's the running out of battery. Anyways, I'm gonna split it on the test video. Okay, I'm back. I just connected the AC to the cam. Sorry about that. I have the two probes of the scope connected to the two end terminals. Let's call them N and S, as in the patent. And I also derive a yellow and a green cable that I'm feeding these two incandescent automotive bulbs. Now the negative of the probes, I'm running it to the negative from the main power source, and the negative also to the light bulbs. Positive is going from the power source, it's going through the slip ring brush, and then getting distributed through the rotating brush. So that PSU over there is just feeding the small motor to make it turn, and that one above is where I'm going to be feeding the main system. Okay, so let me see. Let me start going here. Just gonna go at a mid speed, and then I'm gonna start dialing a little bit of power. I have it on 0 right now. Sorry about that movement on the cam. Okay, and we can see the wave is pretty wide because the motor is going slow. Just gonna lower the intensity a little bit so you guys can see the fluctuations right there. And at the scope, it's pretty wide, but you still see the peaks and the down. I have the two cursors from not aligned so you guys can see. But if I'm going to increase the speed, so the wave starts shrinking because time shrinks here, and you can see the bulb flashing. It's going too fast, so, and I'm just using seven volts and 0.7 amps at the power source. And this is cold. I mean cold. And I'm gonna go higher. I'm gonna go lower because I want to see and brighter here. too low. Let me turn off this light a little bit. So the cam can catch the blinking of it. And as I increase it, speed is going still low. Now it's almost not noticeable, but if we go into the scope, we see the perfect wave there for both parameters. And if we look at the zero line, you can notice they are completely positive. I'm going to try to lower more the currents. Yeah. So eventually when we build the primaries, then of course the wave expanded a little bit. But it is still the proof here that get back the lights on, and that is controlling inductance, and this is awesome because it's cold, guys. This is not gonna spend any power at all, almost nothing. This is just a variation of the currents through inductance, pure inductance within the toroid, and this is awesome. This is awesome. And actually, it's, if you the way Nerica explained it, and I would try also, is simple. It's the currents, the commutator, even though it's spinning in the same direction, because of the kind of connections we're doing here, what the current is going that way to apply max at this end and minimal here, and then coming back this way to apply max here and minimum here, to suck from here and to pressurize output here, and so on. So it's going like that and like that, like that, like that, like that, like that. That's what creates our wave right there, and it happens exactly at the same timing when the current is traveling to provide max at this point, it's providing minimum. So at the time it gets here with max, it's radical minimum here, and it's very, very the unison happens in a very symmetrical way, and at the same token I would say it's asymmetrical, because one is going high, the other one is low. So this is what it's doing. The commutator is spinning one direction, it's going like that, like that, like that, like that. Current is creating a variation in time like that. So this is what generates our wave. Thank you very much. Don't want to take any more of your time. We have a lot of work to do with the primaries. Have a nice day. I am very, very, very happy Thanksgiving to all.